Good morning. In this video, we are going to discuss about a two-block problem, but they are connected by another object, a horizontal rod. Now let us go to the problem. Find the maximum value of the block B for the rod AB to remain horizontal. Also find the corresponding axial force in the rod. Take mu equal to 0.2 for all contact surfaces. Now this is the given problem. There are two inclined plane, one is at 30 degree, another one is at 45 degree. Two blocks are given, one is A which is having 20 kilonewton, another one is having unknown value. Now this is the horizontal rod that supports and connects these two blocks. Now in this case, here the block A tries to move down, and that movement is arrested by this rod AB. Okay, and you know that here when it arrests this movement, it must give some force. Let me take that one as P. This is the force used to support this block A. Now this force depends upon this weight. That's a very important thing to understand. This P, the force value at this rod, depends upon the weight of this block B. That we have to understand. Now in order to remain this rod in horizontal position, what is the value of this block B? So that is what we are going to find. So once we understand the given problem, next step is you have to draw the free body diagram. Now let us go and draw the free body diagram. Now this is the given problem. Okay, let me take the object A first. So this is the body I am going to separate. Okay, and when I separate this body, I have to consider all the associated forces acting in the system. Very important thing. Now this is the block A. There is a weight 20 kilonewton. Then this block is supported by this force P. So this is a force P. There are two forces. Now you see here, this is the surface which gives always the normal reaction. Let me take this one as N. Moreover, when this block moves down, okay, this force will arrest that movement. So this is the applied force P, and now the friction force will act always against this P. So this is the direction of the friction force. So these are the four forces acting in this body. Now this is the given free body diagram for that block A, and also you should know that this is the position of the axis. Okay, when you are dealing with this any such inclined plane, it is better to change this orientation of this axis. As we discussed, this is the weight of the block, and this is the applied force P, this is the friction force, and N1. And since these two forces are neither parallel to x-axis and y-axis, so you have to resolve this force, one along x and another one along y direction. So here I have resolved it. Once you complete the free body diagram, the next work is you have to use the appropriate equation. Now you just check that among these four forces, this is the only known force. So these three are the unknown forces. So minimum you need to have three equations to solve this problem. Now I am going to use the equilibrium equation, equilibrium of particles. Okay, and when I use equilibrium of particle, I have two equations. One is the summation of all horizontal forces equal to 0. The summation of all vertical forces equal to 0. Okay, I need one another equation since there are three unknowns. Now the third equation is the basic equation of the friction, which is nothing but F equal to mu into N. So these three equations are to be used. First I am going to use the first equilibrium equation. A summation of all x component is 0, and in this diagram there are three x components, F1, P cos theta, and WA sin theta, and among these three, this force and this force are having positive sign and this negative sign. So here it is F1 plus WA sin theta minus P cos theta equal to 0. The next equation, summation of all vertical component is 0. So if you consider this, there are three y components. The first one is N1, P sin theta, WA cos theta, and among these three, again this is the only force having positive sign, these two are having negative sign. Now this equation becomes N1 minus WA cos theta minus P sin theta equal to 0. Now we know that the friction can be written as F equal to mu into N, Now this equation, the first equation will become like mu n plus wa sin theta p cos theta. So let me take this one as equation number 2. Now this is equation number 3. This equation can be taken as equation number 3. Now just divide the equation 3 by 2, you'll get something like this: p sin theta divided by p cos theta equal to n1 minus wa cos theta divided by mu n1 plus wa sin theta. Now you can just cancel these two, the p in both the terms. So this will become like sin theta p cos theta equal to tan theta. Now you know that I know the value for theta, it is nothing but 30 degree. So this is the angle 30 degree. So tan theta now it is equal to 0.577. Okay. Now just to do the cross multiplication, let me take this, the denominator has 1. So do the cross multiplication, you will get the answer as something like this. Now in this equation, just to bring the n1 terms in the left hand side and the wa terms to the right hand side. So now this equation will become something like this, and you just substitute now the values. Okay, n1 minus 0.115 n1 will become like 0.884 n1, and in the place of wa just substitute 20, and this is, and in the place of theta substitute 30. So finally you will get the answer for something 23.09 kilonewton. From this one you can get the answer for n1, which is equal to 26.12 kilonewton. Okay, from this one you can get the answer for the value of p, which is equal to 17.579 kilonewton. So this is the horizontal force needed to arrest the movement of this block A, okay, in downward direction. So next, in the given problem, we have to find the maximum value for the block B. Okay, now I'm going to consider the second block B, and I'm going to draw the free body diagram for it. Now before going into that, you have to find the associated forces for this block B. Okay, the first block force is the weight of the block, and the second one is the normal reaction. Okay, N2, and this is the applied force. Okay, you see here the direction is right to left, whereas here it should be left to right. So this is the direction of the applied force P. Okay, in order to have equilibrium at the horizontal rod. Now since this is the applied force direction, the friction force should be just opposite to that one. So this is the direction of the friction force. Okay, so there are now 4 forces acting in this block B. So this is the free body diagram. As we discussed, there are 4 forces: F2, N2, P as well as WP. Now just change this coordinate, x and y coordinate, according to this inclined plane. Now these 2 forces are neither parallel to y axis and x axis. So you have to resolve these forces. Okay, one along x direction, another along y direction. And similarly, this force P has to also be resolved, one along x direction and another along y direction. Once you complete this free body diagram, next go for the appropriate equation. So as we discussed in the previous case, there are 3 equations to be used here also. First one is summation of all x component is 0, summation of all y component is 0. Then third one is the basic friction equations, F equal to mu into N2. Okay, now just apply the first equilibrium equation. Now in this free body diagram, there are 3 x component forces. One is F2 negative, and P cos theta positive, and WP sin theta again negative. And substitute into this equation, get the equation number 1. Okay, similarly for the y component force, there are 3 forces, and the N2 is the only positive force. We just look at this free body diagram. This is N2, and this is WP cos theta, which is kind minus sign, and here also you have minus. So this equation now will become something like this. Now the basic friction equation, which is nothing but F2 equal to mu into N2. Now substitute into this equation in the place of F2. Okay, and rearrange the equation so as that the unknown value WB in the right hand side. Similarly, and now just take this is equation number 2. Now take this equation and WP cos theta in the right hand side, and take that one as equation number 3. Now divide these two equations, 2 by 3, you will get WP sin theta, WP cos theta, and this is the equation. Now you can cancel these two terms, so you'll get the answer as tan theta equal to P cos theta minus mu N2 divided by N2 minus P sin theta equal to In the place of theta, you just substitute 45 degree. 45 degree means this angle. Okay, you'll get the answer as 1. Okay, now just do the cross multiplication. Finally, you'll get the equation as p cos theta minus mu n2 equal to n2 minus p sin theta. Okay, now just to bring this n2 related terms in the left hand side and the terms related to p in the right hand side. So this equation will become like n2 plus mu n2, which is equal to p cos theta plus p sin theta. Okay, now from this one take n2 outside, here p outside. So this equation will become something like this. Okay, now you just substitute the values. Mu, you know the value, it is nothing but 0.2, and the value of p is equal to 17.57, and in the place of theta just substitute 45 degree. Okay, so finally you'll get the answer for n2 as 20.70 kilonewton. Okay, now just take this n2 and substitute it into the equation 3. So here is the equation 3. In the place of n2, you just substitute that value, and then you can get the answer for WP. So here is the WP, which can be taken as 11.71 kilonewton. The corresponding friction equal to F2 equal to 4.14 kilonewton. So this is how this problem should be solved. Again, the summary of this problem is, first understand the given problem very well. Okay, read many times until you get clear understanding. The next one is you have to draw the free body diagram. Okay, very important diagram. Then third one is use the appropriate equations. If there are 3 unknowns, then you need to have at least 3 equations to solve. Then third one is fourth one is do the calculation very carefully. Okay, then the fifth one is you just validate your answers with the given problem. Thank you. We will meet in the next video.